Good morning, ladies and gentlemen. Welcome to UBC Data Science for Social Good 2020 final presentation. My name is Andy Liang, and I'm a fellow of Team NLP this year. Please let me introduce my teammate, Rachel Lawbey, Senior Lu, and Xinya Gao. Our presentation topic is natural language processing of ladder comments for pipeline application. During the presentation, please mute yourself and type in any question in the comment box. We are open to all questions after our presentation. Thank you. In today's presentation, we will first cover project context, including the introduction of our partner organization, Canada Energy Regulator, the motivation and the goals of our project, and have a look on our dataset. Next, we will carefully introduce the method we use in our project. To figure out two key questions, what did people say and how did people feel? We use Lda sentiment analysis and text summarization as our main approaches. To visualize our result, we created a dashboard by Tableau for our Lda and sentiment analysis visualization tool. We will show a demo for our dashboard today. Lastly, we will discuss potential development could be done in the future. First, let me introduce our partner organization, Canada Energy Regulator. Canada Energy Regulator is the agency of the Government Canada under Natural Resources Canada portfolio. It regulates pipeline, power line, energy development, and trade in the Canadian public interest, and make decisions on whether pipeline application get approved or rejected. On August 28, 2019, Canada Energy Regulator replaced original National Energy Board to give more opportunity for the public to express their opinions in public hearings. Through the process of public hearing, other parties and individuals can submit a letter comment to voice their interest and concern on a specific pipeline application. From 2002 to present, there are approximately 11,000 letter comments in total submitted by shippers, energy company, Indigenous people, landowners, and non-governmental organizations. For the example on the right-hand side, it shows some example of comments submitted by public, indicating positive, negative, and neutral feelings on different pipeline applications. Due to a change in legislation allowing broader participation from interested parties, Canada Energy Regulator expected a high volume of letter comments submitted. Currently, reviewing and determining the content of the letter comment is time-consuming and performed manually. The expanded mandate to receive comments from any interested party may make this manual process harder. Therefore, we are going to first explore what people say and how they feel in the past letter comment to better engage with them in the future. And we will try to automate the current process letter comment to support processing a larger volume of letters. The total number of letter comments is 11,000. And they're all in PDF format. We can see on the right-hand side the metadata pertaining to this letter, including personal information, company and institution name, project name, the year submitted, and the comment itself. During the process of extracting information from the entire dataset, we find there are several types of letters are not easy to do data processing and extraction due to time restriction. Therefore, we decide to take this format out, including the scanned PDF, the handwritten letter comment, those letters written in French, the letters containing figures or tables, the letters is rotated or highly pixelated, and all the other formats. The total number of unprocessable subset excluded is 2,319. After excluding unprocessable subset, the remaining letter comment consists of structured and unstructured format. Due to time restriction, after careful discussion with CER, we agreed to focus on the structured format only, and the unstructured format may be mentioned for future work if time allows. Our data processing and all the analysis now are based on the structured format only. The total number of this subset is 4,000, 887, which consists of 3 big pipeline applications, Enbridge, Trans Mountain, and Brunswick. We can see that examples of letters here are all in good PDF format and contain the metadata like the name, institution, and the comment like we mentioned before. We take several approaches to final in order to accomplish the automated process. First, we collected all the letter comments and did the initial data processing step. Based on the data process, we choose topic modeling to have a better sense of topic mentioned in the letter. In the same time, we started sentiment analysis for comment to have an understanding of the public's opinion on the project. Later on, we combine our results from LDA topic modeling with sentiment analysis to incorporate our process. After LDA and sentiment analysis, we did text summarization by text rank algorithm, which figured out what did people say in a sense.
Now I will introduce topic modeling and LDA. Topic modeling is the process of identifying topics within documents using statistical methods. In text documents, topic modeling identifies words that occur frequently together and groups them together to form a topic. Latent Dirichlet allocation, or LDA, is a simple and popular topic modeling tool that we have chosen to use. In LDA, the number of topics is user-defined, meaning that the user specifies the number of topics that they want ahead of time. One clear limitation of LDA is that it returns groups of words that form the topic, but it does not label them for you. So it is up to you to come up with a label for the topic based on the top occurring words. And it can be tricky to label topics if there is a high degree of overlap between them, or if the top words are not very informative. In the letters of comment, we thought that basic LDA to find the main topics within the letters may not be enough because we suspected that topics within the documents would have a hierarchical structure, where main topics would be broken down into subtopics rather than having many unrelated subtopics. So we opted to perform hierarchical LDA. In this process, we first trained the LDA model to identify the main topics. Next, we separated the documents by finding the main topic with the highest probability in each document. And finally, we trained LDA within each topic to identify the subtopics. Since we performed hierarchical LDA separately within each project, we are going to show the results for each project one at a time. We will just give a brief overview of the results in this presentation because we also have a demo. In the hierarchy of results, first we have the pipeline project name at the top, which is the Enbridge project for this slide. What branches from the project name are the main topics, and within those topics are the subtopics. For the Enbridge project, we have 3 main topics, which are longer-term impacts on climate change, such as fossil fuel, economic and government issues, and finally, short-term impacts of oil spills. The first and third of those main topics each have 3 related subtopics. Note that these topic and subtopic names are our interpretations of the keywords, and that other people may label them differently. The second set of letters that we looked at were about the Trans Mountain project. Here there are 3 main topics like with the Enbridge project, which are the impact of oil spills on the natural environment, environmental and energy concerns in BC locations, and commercial impacts of oil spills. While the first and third main topics each have 3 subtopics, the second only has 2. The final set of letters we looked at were the Brunswick Letters. The first thing you may notice is that there are only 2 main topics. We decided not to have subtopics within those letters because when we tried hierarchical LDA, the subtopics were not very distinct, possibly because there were far fewer letters in comparison to the other projects. For the Brunswick Letters, the first main topic is weighing the risks of the pipeline and the interests of the public, while the second topic is more about concerns of people's homes being near to the pipeline, so more like residential concerns. Next, I will demonstrate our dashboard for the LDA results. In our Lda Overview Dashboard, the user can pick one project that they would like to view, and it will show the most frequent topics that people mentioned in their letters. And thus the user can apply the keywords that they are interested in to our Lda Details dashboard and find all letters that include those keywords. On the left side of the dashboard is the Intertopic Distance Map, which illustrates the relationship between main topics. The distance between bubbles stands for the overlap between the main topics, and the size of a bubble is the frequency of how many letters are related to that main topic. For example, for all letters submitted about the Trans Mountain project, we split them into 3 main topics according to our Lda results. Here we see that main topic 2 bubble is slightly larger than the others, which means that people's concerns about this project tend to be more related to that main topic.
And when the user clicks the main topic 2 bubble, it will show the top number of terms related to that topic. Also, they can choose the number of terms they would like to view and change the bar chart to a word cloud for their preference of visualization.
Here is the Lda dashboard that we've created to help users find letters that meet their criteria. Please note by default, all letters from all 3 projects are displayed in the right panel. On the left side, there are several drop-down menus for users to customize their search. For example, if you want to view all letters within one subtopic from our Lda results, they can select one topic from the main topics menu, then select a subtopic to further break down the previously selected subset of main topics. If you want to search for letters that contain keywords that you are interested in, reset the previously selected items to all, then type a keyword in the search bar above the right panel. For example, if you want to look for letters that contain oil tanker traffic, type it there. Then it shows all letters whose contents contain oil tanker traffic. If you click the URL, it will take you to the actual file. Then you can find which sentences that those keywords are located in. All functionalities covered in this demo are shown in the user guide as well. A user can just hover over the light bulb for details of instructions.
In the last part, we demonstrated how useful Lda is in terms of learning the subject of given text. Now we're going to talk about sentiment analysis, which exists to learn what was said about a specific text. Sentiment analysis is basically identifying and categorizing opinions expressed in a piece of text as positive or negative. That's why it's also known as opinion mining. It is widely applied to reviews and social media for a variety of applications, but its limitation is obvious as well. We can do sentiment analysis on several granularities, but that's all it is, positive or negative. It is limited as it flattens the structure of human emotions into a single dimension. That is the reason why we want to go beyond the sentiment, not just positive or negative. Here is an example of emotion detection. We don't only determine whether it is just positive or negative, but also the actual emotion. We see emotion tells us more. Is it fear or sadness, for example? That's an important distinction we don't get from sentiment analysis. So, where does that come into play? For example, we want to track a submitter's emotions throughout the letter so we can do several things with it. We can correlate the degrees of hazard to a specific subject in that pipeline project with the emotions of the submitter. That gives us some analytic. For example, what emotions are for the Trans Mountain, how the emotion change across projects, and also the emotions of the submitter are correlated with the pros and cons of the pipeline project. So if a pipeline project, for example, has a large amount of very negative feedbacks, or say, very angry feedbacks, that can have a detrimental effect on the probability of it gets approved. That is something we would like to take into account. For example, that can allow managers to give that proposed pipeline project some break time before the civil ways are proposed. Here is the emotion overview, part of our final dashboard. The user can compile how the proportion of emotions change across different main topics within one project by selecting the project they would like to view on the left side of the dashboard. Or if the user wants to have a general overview of the differences of each emotion across the projects, they can simply select one or more emotions from the drop-down menu on the right side. Please note, since the dataset is extremely biased to letters that are against those pipeline projects, it would be hard to build a classification model based on the current dataset. Here we would just mainly focus on the top 3 negative emotions instead. Next, I will demonstrate how a user can find the proportions of these negative emotions in a specific letter.
Here we will do a quick demo to help the user find the top 3 negative emotion proportions and the top emotion words related to each emotion in a letter that they would like to view. Please note by default, emotion words from all letters are displayed in the word cloud. On the left side, you can select the document URL that you got from the previous LDA details dashboard. For example, the first one that contains solar tanker traffic, whose number is 648,136. And then let's go back to our emotion details dashboard. First, unclick all and then type in 648,136. And then click Apply button. Now you can view the proportions of fear, anger, and sadness within that document. And if you would like to get a general overview of, for example, which letter is the most angry feedbacks, you can select anger on emotion menu. Then it will show all letters have angry feedbacks in descending order. Then you can click on the document URL to see the words related to that emotion. You can click it again to cancel this selection. If you want to search for letters that contain a specific range of that emotion, you can select that on the percent slider. For example, if you want to look for letters whose anger proportions are in a range of 30 to 50, drag it to the number you want. Then it shows all letters whose anger proportions are within that range. Again, anytime you don't know what the next step is, you can always hover over the light bulb to see the details of instructions.
After sentiment analysis, we would discuss how we summarize the letter comment using the text rank algorithm. Text rank algorithm is an extracted text summarization approach, meaning that the summarization only extracts topic sentence from the original letter without rephrasing or changing it. We compared different algorithms in extracted summarization, including word frequency, Jensen, and text rank algorithm. And we eventually choose text rank, which is more sophisticated and can capture the key sentence better. For the summarization output, we first choose our output summarization should be a fixed number of sentences equals to 5, but we eventually modify this fixed number of 5 to a 20% of the entire word count of the original letter comment, which make more sense when doing summarization. When dealing with the letter containing less than 100 words, we considered it as a short letter, which we will not do any summarization, and the output will be the original letter only. I will now give a brief overview of how we use the text rank algorithm to get summarization for each document. For each document, we first separated the document into individual sentences, and then we created vectors for our sentence by using word vectors. That is, we obtained word vectors that were trained on Wikipedia text for all of the important words in a sentence, and we took the average of those vectors to arrive at one vector for the sentence. The third step was to score the similarity score between each pair of sentences and store them in a matrix. The Google PageRank algorithm, which is a commonly used algorithm, was applied to obtain the sentence rankings, which was created by the Google co-founder to rank web page in their search engine results. The probability of going from sentence A to sentence B is equal to the similarity scores of those two sentences. It is important to know that the sentence with greater overlap, which is also known as higher similarity score, are given higher ranks. Finally, we extracted the top ranked sentence to a summary of the document. Let's take a look on the example of our summarization. On the left-hand side, it is the original letter comments, and on the right-hand side, it shows our summarization output. Our summarization has decent results, as it includes the topic sentence covered in the original letter, like the sentence "I would thusly be affected," and the sentence "I demand in light of these negative impacts." Here's the second sample output. This letter is relatively longer than previous one, and the summarization output changes according to the word count of the original letter. For longer letter, our summarization not only is to capture the key sentence, like "My issue with the proposed pipeline has to do with the potential environment and socio-economic effects," but also includes some details and demonstration like the sentence "Any spill of bitumen will directly result in the loss of my fishing areas." On this page, we are presenting the short letter that we mentioned before. We define any letter less than 100 words as a short letter. This type of letter will not be summarized, and the original letter will be the output here. As we find for short letters, like the first example here, it is hard to capture similarity score for those letters. Our current algorithm has very clear pros and cons that we notice. I will have a discussion of them. Our current algorithm is a very simple way and is fast to obtain the document summarization, with only a few hours to get all the summarization. It is reliable to capture all the original meaning of sentence and take how often words appear next to each other into account. On the other hand, we are aware that the focus of the document summarization may be a single topic, and not all the topics within a document may be included. We propose to implement maximum marginal relevance as a solution. Meanwhile, to have a better ability to pinpoint what proportional sentence best summarize a document can be the next step for future.
Now, I'm going to discuss what we've done so far. First, in topic modeling, we've extracted major topics and subtopics that were discussed in the letters from each pipeline project, a lot of which were concerns about the environment and about the people who lived and worked near to the pipeline. Secondly, we performed sentiment analysis, where we found that fear appeared to be the most prevalent emotion across the documents. To connect the topic modeling and the sentiment analysis, we performed a sentiment analysis within subtopics to understand what emotions were associated with each of them. I think that combining the two gave more depth to our analysis of the letters, and that it helped to connect our goals of extracting what people said and how they felt. Then, we moved on to text summarization for each document using the text rank algorithm. Finally, we created visualization dashboards for topic modeling and for sentiment analysis that help to communicate our results and that allow for the user to search through them to narrow down to what they are most interested in. This slide shows possible directions for further research. I will briefly discuss each direction and occasionally comment on difficulties that are likely to be encountered. Firstly, we think it would be very useful to perform text summarization within the Lda Results, where the top sentences are found within each topic and subtopic to give more informative descriptions of what they mean. Next, to improve the Lda topic results, we could determine the percentage of each topic in each letter and show those results. The third direction is to classify documents using the positive and negative emotions from sentiment analysis to say whether each author has more positive or negative feelings about the pipeline project. An issue with this direction is that it may require a set of letters that are already labeled positive or negative. Because our current dataset has very limited positive feedback, it may be difficult to construct that labeled set of letters for the positive case. So if in the future there are more positive letters, this classification project would be a good research direction to pursue. Another future direction is to identify Indigenous groups' opinions and to perform Lda and sentiment analysis on that subset of that original data. One issue with this is that the current data set has very few people who report an affiliation with an Indigenous group, so this research direction may be more promising for sets of letters about other pipeline projects. Finally, it would be ideal to extend our text analysis to include the unstructured letters that are difficult to process. That seems to be quite a difficult task with the techniques and software that are currently available, but it should be kept in mind because the opinions from the unstructured letters are not included in our results. Hence, our results are biased. Thank you for listening to our presentation, and thank you to the DSSG program and the CER for this term. We are now open to any of your questions.